Now we'll get into the geothermal section, which I think is most applicable to what Faye was saying. She has an oil boiler. So what a geothermal heat pump is it takes heat from the ground. So in this example, you'd have cold. This system is actually in cooling mode, but I'll treat it like in heating. You have cold water. So you have cold air coming in from the top, and the system is heating it up and sending hot air out. Very basic. Where it gets its energy is when the water comes in from the ground. Let's say it comes in at 55 degrees. This heat pump sucks the energy out of it and it sends it back into the ground at 45 degrees. So the way that it gets its energy is it takes 10 degrees, it takes all the BTUs from that water, and then it just puts it into your house. Same principle as what's most classically used is a refrigerator. So what a refrigerator does is basically takes BTUs out of the fridge and dumps it into your house by running a heat pump. So pretty simple technology. All you have is a heat pump. You have a pump package and a controller right here. You can also have it heat hot water, which is kind of crazy. A lot of people don't realize that in cooling mode in the winter, what it does is it takes heat out of your house and it puts it into your water tank. So with people with geothermal and just superheater in the summer, if it's running in cooling mode and they take a shower, they take hot water, that heat that came from there is coming from their house, which is pretty crazy. Comparable efficiency, top quality kind of oil or gas is probably around 90, same thing with wood pellet. Electric resistance is 100%. Air horse heat pump is about 200% efficient. Ground source 500 is pretty liberal. I would say it's much more around the range of like 350 to 400%. And again, the reason why it's so efficient is that the heat that it's taking out of the ground, going from 55 degrees to 45, is free. All you have to get that heat is run a small amount of electricity to run a pump. If you could translate it to like oil, for a random example, you would get 4 gallons of oil for only spending 1 gallon worth of fuel. In heat, it's just BTUs or therms that's used, so you get much more heat than the energy that you actually put in. With the idea that all of the heat that you're getting is coming from your ground loop, and you're not spending any money for that. This is a picture of a job in Wakefield. This is the drill rig. As you can see, it's like pretty big and nasty, and they're drilling. You can see a casing right here. You have to case around the bore if there's kind of sediment or loose particulate, and then the drill shaft is right here. These are the tubes coming up out of the ground. 1.5 inch HPDE. Like, this is literally what heats people's homes. It's kind of crazy how basic it is. These are the tubes coming out. These are wrapped in PVC, so when they're put through the foundation, they're just have a little more protection. This is it going into the foundation. At the left, right here, this is where it came into the basement, and then they're running the coils over. This is a pump package for one unit, and you'll see the pump package for the other unit over here. There's the pump package for the other unit. So basically, what this pump package controls is the fluid that's running to the ground loop, and then it goes over to this compressor. And again, at the bottom one here is where it's coming in at 55 degrees. That compressor is taking the energy out of it, and then it's sending it back to the ground loop at 45 degrees, and it comes back at 55, and it takes that energy and puts it into the home. The interesting thing with geothermal is that one of the decisions for Bill's house was air quality. Because it moves a lot of air and it positively pressurizes the house, it just filters the air much more frequently than, for example, like your steam system doesn't have like any air quality benefits, because you just have these huge like radiators out, and it just heats those up. Geothermal system, because it's moving a lot of air through your house, keeps your air very clean. So a lot of people that have allergies prefer geothermal or some sort of air-based heating system for their allergies. Geothermal takes a lot more, so the drilling, it's pretty standard that a drill rig would get through 1 bore per day. So if you're drilling, well, that could change, but standard bore is between 400 to 600 feet, but Harold did a job that was 1,200 feet, so that was much larger. But typically it takes them 1 day a bore. So if you're having a 5-ton system, you might be drilling 3 bores to 200 feet apiece. It'll take them 3 days. And then the construction in the house takes much longer because you're putting in ducts, so it takes between 3 to 5 weeks. Total on average about 5 weeks. So it takes a lot more and is a little more intrusive than a solar project, but that's because you're like actually building a distribution system in your house rather than just like putting a few panels on the roof. Best properties are larger than 1,500 square feet, no access to natural gas. New construction is the best, or a retrofit if you need to replace your existing equipment, and you have to have like space in your driveway or your yard to fit the drill rig.